Live from the BBC, The Naked Scientists.
A very good evening to you and welcome to this week's edition of The Naked Scientists with me, Dr. Chris, and with Dr. Kat.
Hello!
This evening we have an explosive show in store for you because we are winding back time to the beginning of time. That's right, we're going back 14.9 billion years to the origins of our universe and the Big Bang. What is the Big Bang? How did it all happen? Where did stars, galaxies, planets, comets and solar systems all come from? And here to help us answer some of those questions is from the University of Cambridge, Mike Hobson. Good evening, Mike.
Good evening, Chris.
Thanks for popping in. What sorts of things do you want people to ring up and ask you?
Any questions about cosmology, astronomy, the stars, galaxies, the Big Bang, although the answers to the Big Bang aren't as straightforward as we'd like them to be.
That's Mike Hobson. If you'd like to ask him any questions on anything to do with cosmology and the study of space science, 08459 25 2000 is the phone number. I'll be giving you that lots of times through the show, don't worry if you've missed it. You can also email us, chris@nakedscientist.com. Here with a rundown of what else to look forward to tonight is Dr. Kat.
A veritable plethora of stuff on the show today. I'm going to be bringing you the science behind beer goggles. Yes, what happens when you've had a few and someone who you thought was completely minging looks really, really attractive. Some scientists have been investigating that. Chris is going to bring you a story about... Well, I said it was a seal cam, but in fact it's a seal probe. So scientists have been using seals instead of oceanographers to probe the ocean depths. And we also have, for you, our quiz, Science Fact or Science Fiction, that you can call in on 08459 25 2000 and have a chance of entering that, because the prizes this week are out of this world.
They're quite literally astronomical.
Astronomical prizes this week. We have an astronomical telescope from the wonderful Anne Gray at ScienceSleuth.com. You can see mountains on the moon down this telescope. It's brilliant. It's got to be a prize worth having. We're also giving away the whole Encyclopaedia Britannica on DVD. Woohoo! And a family ticket for a film at the IMAX cinema down in London. I went there the other day.
It's the IMAX where you have to wear those funny multicoloured glasses so you can see films in 3 dimensions. It's really freaky, but God, is it amazing.
Yeah, I saw a normal film there, though, and that was still really and staggeringly loud and big. It was brilliant. But yeah, get phoning in for the quiz, Science Fact, Science Fiction, and any other questions you've got, science, technology, and tonight particularly cosmology, astronomy, where did the universe come from? 08459 25 2000.
And don't forget, very soon we'll be heading over to a kitchen in Kettering, because tonight Derek and Dave, our kitchen science posse, are in Ashley and Olivia's kitchen, where they're going to be doing something very interesting with microwaves and crisp packets. And it's very simple, this experiment. All you need is 1, a microwave, and 2, a packet of crisps. So if you want to take part in that, go and get yourself some crisps and go and get yourself a microwave. And very quickly, we'll be kicking off with this week's Kitchen Science.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
Now, up first this week, exciting news from the Antarctic, because Mike Fedak, who works at the University of the University of St Andrews up in Scotland, is a member of the Sea Mammal Research Unit, and they decided to get together with a group of oceanographers to see if they could help them out, because the way we study the oceans is to go where usually boats are going, and you drop probes off of boats, which are called CDT probes, and they measure conductivity, density and temperature, and to put it simply, they work out how hot the water is, what direction it's moving in, and how saline or salty it is. And this can tell you an enormous amount about what the water's made of, in other words, what's dissolved in it, and it can help you to predict what the weather's doing, what the weather will be doing, and if there's any grounds for claims about global warming and climate change. That's the long-term view anyway. The problem is that there are some parts of the world's oceans where boats don't go terribly often, or boats can't go terribly easily. So, as we found out last week when we reported that Japan Airlines are putting CO2 monitors on their aeroplanes so that they can get real-time 3-dimensional measures of the CO2 levels over Asia, that's what the oceanographers have decided to do in the Southern Ocean, because they've recruited 70 elephant seals and they've rigged them up for sound so that they can take the measurements for the oceanographers. Basically, it's a very simple device, which is about the size of a person's fist, and it sticks harmlessly onto a seal's head. And then when the seal goes swimming around and dives down to the bottom of the sea, then the probe measures lots of things from underneath the water. It makes all the same measurements you would normally get. And seals go diving quite often. They go down to 300 to 600 metres underwater. It's a hell of a deep dive. And they do that roughly 40 times a day when they go fishing for fish and squid to feed themselves. And then when they come back up from underneath the sea, then the probe establishes contact with a series of satellites overhead called the Argos system of connected satellites. And these are like a relay station. And the radio message from the seal's head probe goes via these satellites back to the oceanographer, oceanographers, and they can therefore map out what's going on wherever the seals are, because they can track where the seals are going, and they can find out what the sea where the seals are is doing. So it's a fantastic way to get data for free and to get seals to do it for you.
I want to know what happens when the seals go on holiday. They suddenly get all this bizarre data because the seals have gone off to the Caribbean for a week or something.
I don't know where seals go on their holidays, actually. Perhaps you know at home. Give us a call,
Anyone
08459 25 2000.
Well, I've got a story that's in honour of George Best, who's legendary drinking and womanising, probably took more fame than his football. I love that quote from George Best. He's like, I spent most of my money on beer and fast women and the rest I just squandered. Anyway, scientists have worked out how beer goggles work. So when you've had a few drinks, you're in a club, you find someone attractive that you would not normally find attractive. And this phenomenon is transformational, transforms mingers, basically, into the beautiful people until the next morning, of course. And now researchers at Manchester University have found that it's not just the amount of beer that you drink. So there's things like the amount of light that's in the pub or the club, your own eyesight, so obviously if you're a bit blind.
It kind of goes without saying, doesn't it?
Yeah, I don't know. I've seen some people who ought to have a white stick and a dog. And how smoky the room is. So also, if they bring in the smoking ban, this could reduce the existence of beer goggles. And how far away you are from someone. So if you've got really bad eyesight and you see someone across the smoky room...
Isn't this sort of research into the blinking obvious? I mean, who paid for this?
Well, yes, it was actually commissioned by the eye care firm Bausch and Lomb. So whether they have a vested interest in improving people's eyes.
Sort of going on there, isn't there?
Yeah.
If you want to drop us any emails to The Naked Scientist, chris@nakedscientist.com is our email address. Any science questions or just to say hello. We were commenting last week we hadn't heard from anyone in Brazil, and now we've got two. We've got Scott Kirkwood, who said, I enjoy listening to your podcast here in Belo Horizonte in Brazil. Keep up the good work. That's from Scott. And I've also got an email from Ricardo Duarte, who says, Hi Chris, why is it that we like drinks with gas, like beer or Coke? If we drink these beverages without it, they taste bad, but gas is tasteless. What effect do bubbles have? Is it the sensation? By the way, congratulations, great show, Ricardo in Brazil. What do you reckon on why do we add fizz to
What
drinks?
do I reckon? Because I thought it was maybe the acidity, because carbon dioxide is the gas that makes fizzy drinks fizzy, and that makes something called carbonic acid. But then we stick loads and loads of acid in things like Coca-Cola, so it's not the acidity in it.
Yeah, I think it's the texture. I don't know what you think, Mike, but I think this is down to the texture, because the bubbles in the drink, as you say, make very little contribution actually to the acidity. They make a small contribution, and acids generally taste lemony. So if you taste sulfuric acid, for example, in very dilute concentration, it has...
Did you last drink sulfuric acid?
You can do this. If you get some sulfuric acid, it tastes lemony at very low concentration. So acids do impart a flavour to a drink. But if you look at most drinks, like Coca-Cola, for example, they're so acidic that they'll rot your teeth away in just seconds. They're on par with how acidic your stomach is in terms of their tooth digesting abilities. So the carbonic acid effect of the carbon dioxide in the drinks makes very little impact, makes very little difference. What it does, though, is create a very interesting sensation in your mouth, because when you dissolve lots of carbon dioxide in the drink, if you look at a glass, you'll see that the bubbles all come from one spot on the glass, and that spot is an imperfection on the glass, and it's called a nucleation centre. In other words, it's a sharp point which makes it very easy for bubbles to form there, and so you get a little trail of bubbles. Now, your tongue is a very rough surface, so it's covered in these nucleation sites. So when you take a swig of a drink, you get tons and tons of bubbles suddenly pinging off all over your tongue, and it's a very interesting sensation. It's like having your mouth massaged by bubbles, and I think that is why, although they don't change the flavour much, I think that the bubbles are so nice in beers and fizzy drinks, because they give the flavour this added sort of dimension. They give the drink an added dimension. I
wonder as well whether the bubbles, if in an alcoholic drink like champagne, whether that helps you absorb the alcohol faster into your bloodstream or not.
I've heard people saying this. I don't believe it myself.
You don't think it's true?
I don't think it's true.
I think we should do a sample. If anyone wants to send us in champagne to the Naked Scientists, email chris@nakedscientist.com with offers of fizzy beverages.
It is, of course, Dr. Chris and Dr. Kat, here with you as the Naked Scientists right across the east of England on BBC Local Radio. If you want to ask us a question about anything science, 08459 25 2000 is the phone number, or email me, chris@nakedscientist.com. Our guest in the studio this week from the University of Cambridge is Mike Hobson. He's a space scientist and a cosmologist, which means he understands basically, if you turn the time back to the year zero, what was there and what the Big Bang was all about. So if you want to ask him about that, get calling now. But before then, it's time to head over to Kettering in Northamptonshire, because Derek and Dave, our kitchen science posse, are out there with Ashley and Olivia. So Derek, are you ready to push back the frontiers of science this week?
Yes, we are indeed, Chris. Welcome to this kitchen in Kettering, where we will be making sparks fly, quite literally. And guiding us through this week's experiment, of course, is the man with sciencey stuffed up his sleeve. It's Dave. Good evening, Dave.
Good evening, Derek.
And what have we got lined up today in the kitchen?
Well, this evening we're going to be making some crispy fireworks.
Crispy fireworks, fantastic. And also helping us in this kitchen are two wonderful helpers. Guys, could you just give us your names and ages, please?
I'm Ashley and I'm 11.
Excellent. And yourself?
I'm Olivia and I'm 11 too.
And Ashley, what do you like about science?
I like exploring different things and just finding out about things that you wouldn't usually do.
OK, and what about you, Olivia?
I like asking people questions about what happens in the world and finding out what happens.
Excellent, and there will be lots of opportunities for you to do that. So if you want to ask a question, then just go for it, basically. And remember, everyone, you can do this at home as well. We're doing an experiment here which is going to be extremely easy, and I'll wager that you do have the things at home that you need to do this. It's incredibly easy. All you need is a crisp packet with crisps eaten, which is one of these packets which has foil on the inside, a kind of a foil-wrapped crisp packet, and in addition to that, a microwave. That's it, OK? So what are we doing with these things, Dave?
First of all, we need to get the crisp packet. Now, first stage is we have to eat the crisps. So if you two would like to eat the crisps in here...
Do you like crisps, guys?
Yeah.
That's all right, then. Right, I think we're all going to muscle in here, because, you know, live radio, time is of the essence. Here we go. Oh. Very tasty. Now, here we are. I think we've set a record here. Those crisps have been devoured. Fantastic. Dave?
Right.
He's still eating?
Yep. The next thing we have to do, cut the crisp packet in half. So can you do that for me, Olivia?
So what we really need to do is flatten it out. OK, so you know how you might get crisps and you can kind of tear them down the side so it becomes a flat piece of plastic. Olivia's got some scissors. It's always good to get an adult to help you with this as well.
If we just tear it open so it goes all flat.
Yeah. So you've flattened it out.
Now cut it in half, so you've got two equal halves of the crisp packet.
OK, so we've got two rectangles here, and on the upper side we've got the foil, which is like the inside of the crisp packet, and on the downside it's just, you know, the plastic.
Ashley, do you think you could clean off the bits of crisp which are left on the crisp packet? Now, it's quite interesting if you leave a few droplets of water on the crisp packet. You don't have to, but it might be interesting. Now, all you've got to do is put it in your microwave, set the microwave to full power, and then run the microwave for less than 10 seconds.
OK, now we're not going to do it now, of course, guys. OK, we're going to get ourselves ready, but we're going to have to keep you waiting until the end of the show when we're actually going to be able to do the experiment and find out what happens. But, guys, I mean, we're going to put this thing in the microwave, full power. Olivia, what do you think is going to happen?
I think it's going to burn up.
It's going to burn up. What about you, Ashley?
Yeah, probably just burn up and... really.
Instead of being flat, crinkle.
Right, OK, well, we're going to find out. Dave, we are, as well as being the naked scientists, we are the very safe scientists, so should we be careful about anything here?
Things that have been in the microwave will come out very, very hot, so make sure an adult touches them before a child does, and it'll be fine.
Yeah, but also don't leave your microwave on too long, because if there's really nothing cooking in there, then it's not very good for the microwave. And you at home, you can do this too. I'm sure it's very easy to do at home, so why don't you just get some crisp packets and do it yourself? Eat the crisps, I'm sure you'll enjoy that, and then flatten it out, put it in the microwave, make sure you've rinsed off all the leftover crumbs of crisp on there, and tell us what happens. We want you to ring in and tell us what happens. So the number to call is 08459 25 2000, and you can also email us at chris@thenakedscientist.com. And the first person to ring in with the right answer for the right result will get a prize from us, the Naked Scientist. So what else can you do but go and get those crisp packets and get them in your microwave and find out what is going to happen to them. We're all done here, so join us back in this kitchen in Kettering a bit later on in the show, and we will be telling you what happens and an explanation from Dave. Back to you in the studio then.
Thanks very much, Derek and Ashley and Olivia. Well, if you want to repeat that experiment, get your microwave, get your crisps, eat the crisps and enjoy them. It's one of these funky experiments so you can actually eat the results, which is great. And then give us a call, 08459 25 2000, if you think you know the answer. Remember, up for grabs this evening, we have an amazing telescope, so you can do a bit of amateur stargazing. We also have the Encyclopaedia Britannica on DVD. And we've also got... What else have we got? Oh, IMAX tickets. How could I forget that? 3D cinema tickets down in London. We've got a family ticket, family pack of those. So get calling now. 08459 25 2000. I have a question for you, Mike, from Tara. And she says, what's gravity made of, please?
Wow. What a question. That question would probably fox most scientists. There are various theories of gravity. The most straightforward one was put forward by Sir Isaac Newton, and it's a force that...
to be reckoned with.
To be reckoned with. A man to be reckoned with, certainly, allegedly. It's a force between two bodies that attracts bodies together, and the strength of the force is proportional to the masses of the two bodies, and over the distance between the bodies times itself.
So the bigger something is, the more it attracts something.
The more it attracts something.
Because one analogy I have heard is of a trampoline, and you put something very heavy in the middle of it, and it causes a dip, and that's a distortion in space-time.
Well, that's wonderful. Yes, that's the Einstein view of things. Albert Einstein,
okay.
A few centuries
I'm jumping
later.
the gun. Sorry.
No. Fine. No, you're very well informed. Albert Einstein, a few centuries later, came up with the idea of gravity, as you say, as the curvature of space-time, and that's very often illustrated by a rubber sheet to put a big ball bearing in the middle and take a little ball bearing, and you can sort of fire it off in at right angles, and it'll go round the body in orbit like a planet orbits the sun, and that's a nice picture of what's going on.
Because I've heard people talking about gravity waves and people trying to build gravity wave detectors. What would a gravity wave be? Well,
gravity waves are ripples in space-time that propagate away from a massive body executing some motion. So in the same way as light is an electromagnetic wave that propagates away when you wiggle a particle with charge, like an electron, gravity waves should propagate away from, for example, orbiting binary stars, and they're ripples that propagate through space-time.
We're talking about space science here on The Naked Scientist, Dr. Chris and Dr. Kat, with Dr. Mike Hobson from the University of Cambridge. If you have a science question for us, 08459 25 2000, or email me, chris@nakedscientist.com. Very shortly on the phone, we'll be going to John in Clacton, Clive, who's in Suffolk, and Sarah in Hardwick.
The Naked Scientists, supported by the Wellcome Trust.
Very quick question before we talk to John in Clacton. This is a question for you, Mike, from Tanner, who's age 14, in Big Timber, Montana, US. And he says, "Hi guys, is it true that a person's head can explode if one went out into space without a helmet on?"
Right.
Fact or fiction?
Okay, well that comes about because if you go into space, there's no pressure essentially. So the pressure of any gases you have in your head at the time potentially could split it apart. But I've never done the sums of whether it can actually break apart bone.
If you put a person out in space with no spacesuit, because spacesuits are pressurised, and space being a vacuum, your blood would boil, wouldn't it? Because
yes,
obviously as you go higher up a mountain, water boils at a progressively lower temperature. So one would anticipate in space your body fluids would just instantly boil.
They'd evaporate away. Yes.
And you would therefore have a boiling fluid in an enclosed space, your body, and the fluid's got to go somewhere, so you just go...
It's a nasty thought, isn't it?
Fairly accurate scenario?
Approximately, yes.
OK, I hope that answers your question, Tanner. Let's have a quick chat to John. Hello, John.
Good evening, lads.
Good evening. What's your question for Mike?
Yeah, is it possible to see a gamma ray burst in the sky? Because having come home from the pub one evening in June, and being a sky watcher, and I wasn't drunk, top of the stars.
Right.
And one it was very far up in the distance, but it sort of shone on very brightly just for a second, just like the torch had switched on from it, and it went out.
And it was definitely a star, John. It wasn't a plane or something.
No, it was 100% a star.
Right.
And I watched a documentary called The Hunt for the Death Star.
Right. Sounds like something from Star Wars. Yeah,
which is all about these gamma ray bursts.
Well, I think it's fair to say, though, John, right, that your eyes, the way you see light, your retina in the back of your eye is sensitive to a very narrow part of what's called the electromagnetic spectrum. The electromagnetic spectrum are all of the wavelengths of light. And they're very, 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 very broad range of lights. There's microwaves, which we can't see, and which Dave and Derek are experimenting with in Kettering tonight. Right. There are X-rays, which can see straight through you, and they can see your bones because your bones mop them up and the other bits of your body don't, but you can't see them. And then there are gamma rays, which are even more powerful than X-rays, but you can't see those either. So I think what you saw almost certainly can't be a gamma ray burst. But it could have been another phenomenon. What do you think about supernova, Mike?
Well, gamma ray burst, I very much doubt. Chris is absolutely right. The light coming from a gamma ray burst will be at a completely different frequency to the sorts of frequencies to which your eyes are sensitive. Your eyes are sensitive to this very narrow range of light, so it can't really be a gamma ray burst. You'd have to describe the phenomenon to me a little bit more carefully for me to have a chance, but to explain it, did it just flash on and then go off again? Or?
Yeah, it's just, as I say, I was watching the stars in the sky, and the star just automatically just sort of flashed on like a torch and went out in half a second.
I think we're going to have to say this is a phenomenon we can't explain, John, but in the interest of time, do you want to have a quick go at the quiz?
Okay, chaps.
Now, because we're short for time this evening, we're going to ask you just one, all right? And then if you get it right, you go in the hat.
Okay, mate.
Okay, here we go then. A jiffy is a recognised unit of time. Fact or fiction?
Jiffy. Fiction.
No, apparently it's true. A jiffy is the term for 1/100th of a second, so you've lost out on the chance to win a telescope so you could see what was up there properly.
But I think, it was a great question though, John, and thanks very much for joining us.
Thank you anyway.
Good to have you on the show.
Yeah, thank you.
Let's have a quick chat to Clive, who's in Suffolk. You are listening, of course, to The Naked Scientists, Dr. Chris and Dr. Kat, and if you want to get a question in, it's very busy on the phones. Up for grabs, astronomical telescope, very nice. IMAX tickets in London, and also... What else?
The Encyclopaedia Britannica on
Yes!
DVD, woohoo!
And that's a fantastic prize because it's worth nearly £100. Hi, Clive.
Oh, hello.
How are you?
All right, thank you.
What's your question for Mike?
Well, I've got another gravity question. We're told that photons can't escape from a black hole. And I was wondering if gravitons can't escape from a black hole. And if so, what are the consequences of that?
You better explain what these particles are first,
right?
so
okay.
everyone else understands the question.
Well, that's a very good question. Yes, photons are light particles, okay, and indeed you're quite right that they can't escape from black holes. That's why they look black. Gravitons are thought to be, this is coming back to the early question about gravity, that an even more modern explanation of gravity is that it's mediated by particles called gravitons, which are massless spin-2 particles.
Which sound like some kind of space alien. The gravitons are here.
That's right, yes. Well, they are particles, fabulous particles, that are supposed to mediate gravity. Now, you're quite right that classically these particles... well, if the gravitons couldn't escape from a black hole, then you'd have a problem that the black hole couldn't actually mediate the gravitational force, so you wouldn't actually feel a gravitational force around a black hole, which of course we believe isn't the case. There are some quite technical reasons for how particles can escape from, can mediate a force even though they're in a black hole, and in fact the reason is you have different things called longitudinal and transverse types of these particles, and certain types can and certain types can't mediate forces from within the event horizon of a black hole. It's a very technical area which I could go into at length if you want to.
Please don't.
You're going to need to employ relativity to get away with that, Mike, because we've only got 35 minutes left of the programme. Do you want to have a quick go at the quiz, Clive?
I'll have a quick go then.
That was an excellent question, by the way, Clive.
Excellent
That was
question,
really
And I think you can safely say that you stretched Mike a little bit there,
Well,
as would happen if he was on the event horizon of a black hole. Right, a bathymeter is used to measure the depth of a swimming pool. Is that science fact or science fiction?
Fact.
No, a bathymeter is in fact an instrument for indicating the depth of the sea beneath a moving vessel like a boat. Or a seal cam, I should think, as well.
Good try, Clive.
Yes.
Thank you very much.
Bye-bye.
It's The Naked Scientists, Dr. Chris and Dr. Kat, as The Naked Scientists, here with you until 7 this evening on BBC Local Radio right across the Eastern Counties. If you'd like to ask us a question, we're talking space science, the origin of the universe, the Big Bang, planets, stars, everything like that. If you want to have a go at that, go at Mike Hobson and ask him a question. He's from Cambridge University and he knows all the answers. 08459 25 2000, or you can email them in to me, chris@nakedscientist.com.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
Now, one thing we did ask of you about a few weeks back was if anyone wants to send us in their own homemade podcasts. So, in other words, if you don't know what a podcast is, it's just literally an audio file which has been put, I don't mean someone who loves music, an audio file, a computer file, which is of an audio program which you can put on the internet and other people can download. And The Naked Scientist is available as a podcast each week. So even if you miss the program, you can go onto the internet to nakedscientist.com and you can download the program as a podcast and listen to it in your own time. But we want you to send us your podcast. So if you're doing something exciting and interesting somewhere bizarre, you're going somewhere interesting, or you already do something scientifically interesting, why not record yourself talking about it? We want something about 1.5 minutes long, and we'll broadcast them on the programme. We got the first contender this week, which has come from the American Society of Microbiology over in the US, and Regina O'Brien this week is going to explore the 5-second myth. Do you guys know what the 5-second myth is?
No.
No.
Okay.
Is that how long goldfish can remember things for?
No. Goldfish actually have very good memories.
Really?
Of up to a year.
Is that how long radio presenters can remember things for?
Yes. No, the 5-second rule is actually, I don't know where this urban myth comes from, but it's the idea that if you drop a piece of food and it lands on a surface and you pick it up again within 5 seconds, then it's not infectious and you can eat it as if you'd never dropped it. Fact
Right.
or fiction?
Let's find out.
Let's find out.
Have you ever heard of the 5-second rule? It's a popular urban myth that says if you drop food on the floor, it will be safe to eat if you can pick it up in 5 seconds or less. We'll take a look at the 5-second rule and separate fact from fiction. During a summer research apprentice program at the University of Illinois, Chicago High School student Jillian Clark and microbiologist Meredith Agel put the 5-second rule to the test. In looking at swabbed samples they took from floors at various high-traffic locations on campus, the scientists found no countable bacteria. The floors were essentially microbe-free. Next, Agel and Clark went to a hardware store to buy some tiles, which they sterilized and then inoculated with bacteria. Dropping bits of food on the tiles and then picking them up in less than 5 seconds, they took these morsels back to the lab. It turns out those morsels were loaded with microbes. So the bad news is the 5-second rule is a complete myth. If there's bacteria on a surface, food picks it up instantaneously. The good news, though, is that dry floors don't support microbial growth, so you probably won't get sick from eating that candy bar you dropped on the floor.
So if you do drop your lunch on the floor and you're going to go around eating it, then you can only blame yourself if you catch something horrible. That was Regina O'Brien from the American Society of Microbiology with our first podcast pick. So if you'd like to send us a podcast on anything to do with science, technology and medicine, we'll broadcast it on The Naked Scientist and you get to advertise what you do a little bit if you're doing something interesting out there in the world of science. Just send them to me, chris@nakedscientist.com.
You are listening to The Naked Scientists on the BBC in the Eastern Counties. If you've got any calls tonight for our scientist, Mike Hobson, all about the Big Bang, the origins of the universe, what's out there in space, what can you see, what can't you see, get calling in 08459 25 2000. And also, if you want to have a go at our quiz to win a telescope, you can win the Encyclopaedia Britannica, loads and loads and loads of stuff to win. Get calling in now, 08459 25 2000. You can also email us at chris@thenakedscientist.com because we love your emails and you love us too. We have some emails here. Here's from Suresh, who's actually in Urbana, Illinois. One of our listeners who's listening on the podcast from thenakedscientist.com. He says, I listened to your podcast on the way to work. After a long search, I found these audio files. He loves the way the programme's presented, and he wished there was more than once in a week. So I think we do too. That would be great, wouldn't it? We could be on every day.
Let's have a quick chat to Sarah, who is on the line. Hello, Sarah.
Hello.
Good evening, and you're through to Mike.
Hello.
Hello, Sarah.
Go ahead,
Hello.
Sarah.
Yes, I just wondered, my son's particularly interested in the universe and astronomy and stuff, and he wants to know, and I want to know too, how far is the nearest galaxy?
That'd be the Andromeda, wouldn't it?
That would be Andromeda, yes. That's about 2 million light years away, something of that order, the Andromeda galaxy.
that not including the one that we're in?
That's no. Our galaxy...
The nearest galaxy, not the Milky Way, yeah.
Yeah, the nearest galaxy that we're in is the Milky Way, and that's a huge spinning disk with spiral arms. That's about 100,000 light years across. But the nearest external galaxy, indeed, as Chris says, called Andromeda, is about 2 million light years away.
What does it look like? Does it look like the Milky Way?
Yeah, well, it's very hard to know what the Milky Way looks like because we're sat right in it, of course, but you can do measurements which try to map out the distribution of matter in our own galaxy, and you can then create a picture of what our galaxy would look like if viewed from outside, and that's how we know that it's this lovely plane spiral structure. And Andromeda indeed does resemble it in many ways. So it's
because
like
historically, people thought that there were no other galaxies, and the Milky Way was the only galaxy, and that all these other little blobs and the smudges in the sky that we now know are galaxies were just what they called nebulae, which is a word from Latin which means clouds, and so they just thought that they were dense clouds of gas making new stars. And it was only a few other measurements that showed, in fact, they were far too far away to be part of our own galaxy.
Absolutely true, that's right. I mean, even Einstein fell foul of misconceptions of that sort, and when he developed his theory of relativity to explain gravity, he had to put in by hand a term to make his universe all nice and stable, because he thought the universe should just consist of these fixed stars, basically.
Sarah, do you want to have a quick go at the quiz? You can win your son a telescope.
Oh, I'd love to, yes.
All right, here we go. A blue whale's heart beats about 30 times a minute. Is that science fact or science fiction?
Fact.
No, unfortunately, bad luck. A blue whale's heart is about the size of a Volkswagen Beetle, and it weighs 1 ton. As such, it only beats 9 times a minute. So bad luck, Sarah.
Oh, well.
Thank you for having a go, and it was a great question.
Thank you.
All right?
Thank you.
See you soon. Bye. Sarah in Hardwick. If you'd like to ask the Naked Scientist a question, we're talking space science this evening. 08459 25 2000, or you can email me, chris@nakedscientist.com. In a second, we're going to be finding out how scientists in America have turned bacteria into miniature cameras. That's with Chris Voigt, who's in California. He's on the line and will be joining us shortly. But first of all, I've got an email here from Singapore for you, Mike. It's from Brian Chin, and he says, "Dear Sir, I'm from Singapore and I've been listening to every episode of your Naked Scientist programme on the internet. Just out of curiosity, how do scientists check the distance between planets, and how accurate are their methods? Cheers, Brian."
In recent times, the methods have been very accurate, because in terms of the planets in our solar system, we've actually sent spacecraft there, so we can do timing measurements from spacecraft. So they're incredibly accurate, and that's basically the way that it's done now.
But in the old days, people had to do incredibly painstaking measurements just to see whether things were moving a tiny bit, and the area of the parallax.
That's right. I think what surprises many people is that Pluto was only discovered in the 1930s. I mean, so it's fairly recent that we've had any idea of the outer reaches of our own solar system. So.
I'd like to know, you hear about people talking about the mass of the sun, sort of how heavy it is.
Yes.
How on earth do you weigh a star? You can't put it on the scales.
You weigh it by dynamically. Gravity is a force, and as the planets orbit the sun, that force keeps the planets circling, and by measuring the distances and the masses and the velocities involved in the dynamics of the planets orbiting the sun, you can measure the sun, and it comes out to be 10 to the 30 kilograms.
That's
10
big.
to the power of 30 kilograms, roughly.
That's pretty heavy.
Stripping down science.
OK, let's do it.
The Naked Scientists.
And now we go over to the US, because Chris Voigt is a scientist from the University of California in San Francisco, and he has succeeded in producing, with his colleagues in Texas, a bacterial photographic film. Good evening, Chris.
Hi.
Or I should say for you, it's not good evening at all, this is good morning.
I know, it's early Sunday morning. Yep.
So now tell us, Chris, what have you done?
So what we've done is use genetic engineering to create a strain of bacteria that's able to respond to light. And the way that we do this is, if you look in a pond, like a dirty pond, you'll see a green sludge that's there. Well, that sludge sometimes is bacteria, and the reason it's green is because it is able to do photosynthesis, and so it has to be able to see light. So we took a gene from that bacteria that's in that pond, and we modified it so that it works in a bacteria that normally is living in your gut, that doesn't have to see light.
E. coli.
That's right, E. coli. And so by bringing in this gene and doing a couple other modifications to the genome of the E. coli, we made it so that individual E. coli cells are able to see light.
And when you shine a light on them, what does it do to the bacteria?
So it has a special type of protein, which is a molecule. Much of the bacteria is made of protein. And this protein is on the surface of the bacterium. And it's special in that it has a chemical that when light is shined onto that chemical, then it changes the shape of the protein. And this change in shape of the protein is recognized by the bacteria, and this leads to turning on a gene. And so in this way, you can couple shining light on the bacteria to the activation of a gene.
And what sorts of things have you made it activate? Because in your paper that you published this week, you've actually made some bacteria change colour. But what else could you do?
So you could imagine using this for a wide range of applications. For example, in thinking about constructing complex materials. So it's very hard to work with proteins, just from a chemistry perspective. And it would be useful if you were able to print proteins with very high resolution. And so we're thinking about using this system in order to have individual bacteria turn on the production of proteins that maybe produce a particular type of material like spider silk, or possibly do some sort of interesting reaction.
Because if you bought these bacteria as a digital camera in the shops, what number of megapixels would it say on the box?
So if it is able to turn on individual bacteria, it would be about 100 megapixels.
So that's incredibly tiny resolution you can work at, so you can make really, really fine structures like this.
Exactly. So each bacteria is like a pixel on a computer screen.
Are these bacteria dangerous at all? You're talking about using them in all sorts of applications. Are they, because they came from our guts, they're not harmful, are they?
No, they're completely harmless. So actually what we're using is known as a lab strain of E. coli. And this differs from natural strains in that almost 25% of its genome is missing. And so specifically, this strain of bacteria is used frequently in the lab because it's a very safe strain.
So it's nice, it's had all the bad stuff taken out of it.
Everything's been removed. Everything that's sort of unknown or bad has been removed.
Stripping down science on BBC local radio in the Eastern Counties. The Naked Scientists. Call now on 08459 25 2000 or email chris@nakedscientists.com.
Sorry, there was a sudden loss of Chris Voigt. There must have been some kind of aberration with the satellite between here and America. We'll blame Mike for that. Mike, got an email here from Bob, who says, Bob Ferry says, from a scientific rather than a religious point of view, why is there or should there be a universe? Why isn't there just nothing? Nice, easy question for you.
Right, okay,
Whoa.
that's a good one. Well, it's thought, in fact, that most of the matter that we see in the universe today probably did come from nothing. By nothing, I mean the vacuum. There is the favoured mechanism for creating the matter that fills our universe is, in fact, conversion of the energy density of the vacuum, which in simple terms one would think of as nothing, no material, into matter. So in some ways, all of the universe that we see did come from nothing.
There was nothing and then it exploded.
Well, the way the energy density of the vacuum is converted into matter is quite a technical procedure, but it's thought that that's how it occurred through a process called inflation.
And how do we measure how old the universe is?
Well, there are a number of ways to do that. The best thing one can do is, firstly, one can measure the ages of things within the universe, okay? So you can measure using radioactive isotope decay rates the ages of the Earth, for example, and one gets about 5 billion years or so. And, of course, one can then measure the ages of stars, and that's often done by modelling the stars themselves and understanding their characteristics in terms of their temperature and luminosity and so forth, and then one gets 10 billion years or so. The universe itself, essentially, one can measure the rate that it's expanding and factor in all of the matter in the universe that tries to slow the expansion down, and one comes with a figure. If you wind time backwards, the point where everything collapses back to a point ends up being around 15 billion years ago.
So that's pretty old for the universe, 15 billion years. Helen is in Norwich. Let's have a quick chat to Helen. Hello, Helen.
Hello there.
Good evening. Welcome to The Naked Scientist.
Thank you very much.
What's your question for Mike?
Obviously, with the sun being essential to absolutely everything on the planet,
Yes.
how do scientists actually measure the lifespan of the sun?
Right. Well, we can't actually observe any single star evolving because the timescales involved are far too long. As I just mentioned, our sun is sort of middle-aged at the moment. Okay, it's about 5 billion years old. It should be kicking around for at least another 5 billion years or so. And the only
reassuring thought, that, isn't it?
Yes, one needn't worry quite yet about it. The way that one understands stars really is by modelling their structure and then observing lots of examples of different stars in different stages of their evolution and seeing if the collection of observations you make fits the theory. And this was a theory that has developed over the years but was pretty much put to bed in the 1960s. And we believe at least that we understand the structure of these stars, and so it's essentially a theoretical construct. We have a model for what stars should look like. It matches all of the stars that we see, and so when we look at the sun, we know what type of star it is, we look at its properties, and we can say it's about 5 billion years old.
Crikey.
Something that won't take 5 billion years, Helen's a go at the quiz. Could win yourself a telescope. Do you want to have a go?
Yes, please.
A chameleon's tongue is twice the length of its body. Is that science fact or science fiction?
Science fact.
Hey, we got someone in the running for the telescope. Yep, chameleons have tongues capable of reaching out to snap up flies over a foot away.
Not bad going. Helen, thank you very much for calling in.
Thank you.
You're listening to The Naked Scientist, Dr. Chris and Dr. Kat. We're here with you until 7. If you'd like to ask Mike Hobson, who's our guest this evening, a question all about space science, cosmology, the birth of our universe, 08459 25 2000 is the phone number, or you can email me, chris@nakedscientist.com. Up for grabs this evening, IMAX tickets down in London to see a 3D movie, or the Encyclopaedia Britannica on DVD, or, of course, we also have a fantastic telescope to give away. I must flag up, last week, if you were listening, you probably remember that we were extracting DNA from school children all across the eastern counties, and they sent us the samples of DNA that they collected so that we could work out who got the purest sample. But just in case you missed it, here's a little recap of what happened last week in schools right across the east of England.
We've been getting samples of our DNA.
How are you doing that? What's the sort of gear you've got there to do it? What's the equipment like?
We've got all test tubes and pipettes and water baths and loads of equipment. We chew on our cheeks.
And then what do you do once you've chewed on your cheek for a little while?
Well, we got a bottle of water.
Yep.
We put it in our mouth and we swirled it around, and then we have to spit it out in a cup. We were using a pipette to put 2 millilitres of lysis buffer into the mixture.
And what does that do exactly?
It opens up the cells so that the DNA comes out.
Okay, do you reckon you're going to win?
Yes.
Okay, why is that?
Because our school's the best. We're adding the ice-cold alcohol into the DNA so that when the alcohol goes into the files of DNA, you can actually see the DNA.
Oh, it makes the DNA appear?
Yeah.
Fantastic, so it's actually working?
Yeah, it's working. We have just put the DNA into the necklaces and into the tubes.
So you've actually finished?
Yes, we have.
What does it look like?
It's a bit like cotton wool, but a bit looser.
Yeah.
And it's white and it's lots of strands of it.
And is that what you expected DNA would look like?
I think it was, yes.
Some people say it looks a bit like snot. Would you agree with them?
No.
That's what happened last week on The Naked Scientist. In fact, Biorad, who donated the kits so that all of those children in Wroxham School in Potters Bar in Peterborough, Dogsthorpe Primary School in Cambridgeshire, the Birch School in Essex, Colby Primary School in Norwich, Norfolk, and Brambleside Primary School, Kettering, Northamptonshire, and the Horringer Court Middle School in Bury, all managed to do that experiment. But who has won? Well, I've got the winner on the telephone. Hi, Saeed.
Hi.
Right, I bet you want this result, don't you?
Yeah, definitely.
Yeah, so you found lots of good DNA?
Yeah, a lot.
Okay, well, I'm really pleased to say you've won.
Yay!
So can I take it by that reaction that you're quite pleased?
Yeah, definitely. Everyone is.
OK. And have you enjoyed taking part in this Naked Science experiment?
Yeah.
Well, I think we're going to be grateful because you've probably rescued our production team. So thank you very much to Saeed and everyone at Dogsthorpe Primary School.
Thank you.
Cheers, see ya.
See ya.
So that was them extracting their own DNA. But this week coming, we have a really exciting experiment going down because we're going to do on radio the first ever example of a live DNA fingerprinting race. Because Billericay School in Essex, Astley Cooper School in Hertfordshire, Mildenhall College of Technology in Suffolk, Downham Market High School in Norfolk, Southfield School in Kettering and Parkside Community College in Cambridgeshire will be racing to see who can be the first in the line to genetically fingerprint a villain. It's a real-life bit of forensic techniques going on here. Someone in the Naked Scientist has got tremendously and criminally smelly feet, and they abandoned a toxic pair of socks in the showers. We've got 5 suspects who we think were responsible. We saw them on CCTV, but none of them will own up to owning these socks. Who was it? We've got DNA from the socks, and we've got DNA from the 5 suspects. Those schools have all been supplied with genetic fingerprinting equipment, and teams there, coming up next week, will be racing to see who can nail the villain first. And those that do will win all of the equipment needed to do that genetic fingerprinting exercise, so other people in their schools can carry on doing that very fantastic experiment forevermore. It's going to be fantastic stuff next week on The Naked Scientist. Don't miss it when we'll have a special forensic science extravaganza for you. Right, very quickly, let's have a quick chat to Susie, who is in Lincolnshire. Hello, Susie.
Hi there.
You got a question for us?
Yeah, I'd like to know how many human years are in light years.
Right, okay. A light year is a measure of distance. It's the distance it takes light to travel a year. So it's the distance light travels in a year is a light year, okay? So it's not actually a measure of time, it's a measure of distance.
Not like animal years to human years then.
No, but it's a nice idea. It would be great to have some astronomy textbooks with dog years as the units. That would be quite entertaining, I think. No, it's a measure of distance and not time. Rather confusingly, though, I admit.
The sun doesn't live 7 years for every human. Like
not as far as we're aware, no.
Shame, really.
Shame.
Do you want to have a go at the quiz, Susie?
Yeah, go on then.
OK, the chemical symbol SN stands for strontium. Is that science fact or science fiction?
I'd say, let's have a think now, as if I know. Let's go for fact.
Ooh, that was quite a hard one, though.
No, SN is what used to be mined in Cornwall. It's the symbol for tin.
Oh, OK.
Unlucky, Susie, but a great question nonetheless.
Thanks a lot.
Thanks for joining us on The Naked Scientist. Susie, who is in Lincolnshire, if you want to have a go at our quiz, science fact or science fiction, you could win yourself an astronomical telescope, an Encyclopaedia Britannica on DVD, or IMAX tickets for a 3D movie down in London. 08459 25 2000 is the phone number, or you can email me, chris@nakedscientist.com. Now, we have to talk to Elizabeth, who is in Kettering. Hello, Elizabeth.
Hello.
Now, you've been doing our science experiment this evening, where you put a crisp packet after you eat it in the microwave.
Yes.
What happened?
Well, sparks came out of it, and
Yep.
when I opened the microwave, it had kind of gone into a lump and it was solid.
Right, why do you think that happened?
Don't know.
Are you inquisitive to find out?
Yeah.
OK, well, I'll tell you what, Elizabeth, stay on the line, because we'll go back to the kitchen and find out from Derek and Dave what's going on, and then they'll give you the answer, and then you can have a go at the quiz as well. Is that all right?
Yeah, sure.
OK, then, stay on the line, OK?
Okay.
Just before we go over to the travel mic, got a very quick little question here. I'm not really sure I understand the question, but it's from E.M. Morgan, who says, please explain why, if our weight is the difference between gravity and the centrifugal force of the Earth's rotation, why are we not crushed if at either pole area?
Right. He's quite right that there's a force of gravity on us, the Earth attracting us, and also because the Earth is rotating, there's a centrifugal force. You can think of it in that way, in the opposite direction. We're not crushed at the pole because the force of gravity is not strong enough to crush us, and in fact, the very small variation in gravity with latitude due to the Earth's rotation is tiny. So it's a very tiny effect. But he is right to point it out. It's different from the poles and to the equator.
Laying the facts bare, The Naked Scientists.
Dr. Chris and Dr. Kat here with you as The Naked Scientist through until 7 o'clock this evening. If you want to ask us a question, 08459 25 2000, or you can email me, chris@nakedscientist.com. We're talking space science this evening, but we've also had an experiment on the go in kitchen science. Derek and Dave are with Ashley and Olivia, and they've been eating the results of their experiment. You had to put a bag of crisps after you'd eaten them in a microwave and see what happened. we had Elizabeth from Kettering who phoned in to say that her crisp bag went all rumpled up and stiff. Why was it? Shall we go back and find out from Derek and Dave exactly what the science is behind all this?
Yes, hello, Chris. We're still here in this kitchen in Kettering with our two helpers, Ashley and Olivia, literally itching to get that crisp packet going in the microwave. And Dave's here as well. Are we all set, Dave?
We're just about there, yeah.
Good stuff. OK, so we're all ready. Olivia's got her hands on the door there, so...
OK, so, Olivia, if you'd like to set the microwave going. I'd like to stop it.
Right, what did you see, guys?
It all sparked and then it crumpled up. It was all smoky.
Now, I seem to remember that one of you actually predicted something like this. I'm feeling one of you got it right.
I said it would sort of burn up and go all crinkly.
Well, I think you were quite right there. So, yeah, now, what can you smell? Can you smell anything?
Yeah, it smells of burning. Yes, like a smoky, fiery smell. Yeah.
Now, also, what we'd like to do is get it out, but I think we're going to let Dave, the prescribed adult here, check that it's not too hot.
Oh, it's cooled down now. That's brilliant.
OK, that's fine. Now, here we go. So, guys, let's have a look at this. What's it like? What does it feel like?
It's really hard. Yeah. How it's crumpled up, it's got all the way the droplets of water were. They've got all bubbles and...
So we've got these little bits of plastic where the bubbles of water were, and they seem to have stayed the same. You can kind of still see the writing that was on the crisp packet. Yeah. But the rest of it's all shriveled up, hasn't it? And it's a lot... Yeah. Well, do you think it's a lot harder as well?
It's almost like a tortoise shell, almost.
OK, well, the question we are all burning to know, just like this burning crisp packet, is what is going on here, Dave? So why don't you explain to us what's happening?
OK, now a crisp packet's made out of two layers. There's a layer of plastic at the bottom, which is it's thicker, and a really, really thin layer of aluminium over the top. Now, the way a microwave oven works is inside it there's a thing called a magnetron, and this makes microwaves. Now, microwaves are kind of light. And in the same way as a water wave will wobble a boat up and down, they wobble electricity backwards and forwards. Now, the aluminium in this crisp packet conducts electricity well, so you get lots of electricity wobbling backwards and forwards through it. And the aluminium will get really hot as all this electricity flows through it. So now we'll think about what's going to happen to the plastic. So if we come over here, we've got another experiment.
OK, now what Dave's got here is a kind of a plastic polythene bag and a hairdryer, basically. So what are you doing with these?
Well, what we're going to do is we're going to heat up the polythene bag with a hairdryer and see what happens to it. And if Olivia could turn on the hairdryer and keep it in one place on the polythene bag. Turn it on. What's happening to it?
It's creasing up.
Can you see it shrinking?
Yeah. Really good.
OK, should we turn that off now?
OK, Dave, what's happening here?
If you heat up a polythene bag, it will shrink down much smaller. OK? Now have a look at the reason for why that is. Now, plastic's made up of molecules. Everything's made up of molecules. Yeah. But the molecules of plastic are really long and thin, like bits of spaghetti. So if you looked at a polythene bag through a really big microscope, it would look like a huge, great vat of spaghetti. Down here, we've got a piece of cable to model one of those bits of spaghetti. OK, so we come down onto the kitchen floor.
OK, so what Dave's done is he's got a piece of electrical cable, which is a little model for the molecules in plastic.
OK.
And it's on the floor here.
Before they make the polythene bag, the molecules in the plastic are all wiggly and wiggled all over the place, sort of at random. OK? When they make the plastic bag, they stretch it out into really thin film. OK, so could you stretch out the molecule really long and thin? Keep going, stretch it, stretch it. So now we've got a stretched out molecule, really long and thin.
OK, so the cable is stretched across the floor here.
Now, heat is how much things wobble. On a molecular scale, it's how much things are wobbling. So in this model, we're going to heat it up. So can you wobble the middle of the molecule? Really wobble it, really heat it up loads. Heat it up more than that, loads and loads and loads. That's brilliant. OK, so what's happened to the molecule now, Ashley?
It's all tangled up and just come together.
Yeah, OK, so instead of being a long, thin molecule, it's kind of all wiggled up and gone into a short, round, wiggly molecule again.
So is that what happens to a plastic bag or a crisp packet?
Thank you. Both the plastic bag and the crisp packet, the molecules start off stretched out really long and thin, and when they heat up, they all wiggle back shorter, and so it gets shorter and fatter. And do you remember it was much stiffer? And because it's so much fatter, it gets a lot stiffer too.
So that's what happened to plastic, really. So with this little model here, when you were wiggling it around, you were just heating it up, really. You're heating up the plastic and making it all scrunch up again, just like we saw.
Why do you have to wash the crisp packet before you put it into the microwave?
Well, if you remember the droplets of water which you had, did you remember the bits on the crisp packet? They weren't shrunk down at all. That's because they kept the crisp packet cool. so they didn't get hot enough to shrink.
Oh.
So you can kind of see some bits of the crisp packet stay big and the other bits shrink down, so you can kind of see what's happened.
The other thing that you noticed was lots of sparks on the top.
Yeah, it's like, you know, in a film where if someone, an evil genius, creates something, there's all different sparks. It's like an electric shock or one of them.
Absolutely, it's like the creation of Frankenstein, isn't it? Yeah, they kind of give him a spark of life. It looked just like that, yeah. So what was that about, Dave?
Well, as the crisp packet as the aluminium gets really hot and as the crisp packet shrinks, you get little gaps in the aluminium. And the electricity wants to flow across the aluminium. In fact, it wants to flow so much, it will actually jump out of the aluminium as a spark across the gaps. So you get all these little sparks as it shrinks down.
Wow, that's really good. Yeah.
So, guys, what do you think of that experiment?
I would never have guessed if I heat it for about 7 seconds that it would just shrink. Yeah. And become Frankenstein.
So that's what we've done in this kitchen in Kettering. We have turned a crisp packet into Frankenstein. So, have you enjoyed the experiment we've brought to you today?
It's really good. Yeah.
Well, it's been our pleasure to come to your kitchen, and Dave's pleasure too, I'm sure. Have we enjoyed it, Dave?
It's been great.
Fantastic. So it's back to you in the studio, and there'll be more Kitchen Science next week at the same time, and I do hope you can join us then. Goodbye.
Thank you, Derek, creating Franken food live in the kitchen. Brilliant. Elizabeth got it right. Hello, Elizabeth.
Hello.
You've done very well. Your observation was spot on. Do you know what you've won?
No.
You've won yourself a fantastic telescope,
Oh, thank you.
which is just in time for Christmas.
Thank you.
All right? Thank you for joining us, and thanks for having a go at Kitchen Science.
Okay.
All right? Bye.
Bye.
Right, remember next week, of course, for our show next week, we'll be having a DNA race right across East Anglia. It's a forensic show, and DCI Tom Harper from Essex Police will be here to tell you how the police use science to solve crimes, and Tamsin O'Connell, who's an archaeologist from Cambridge University, will be coming in to talk about how chemistry can help you find out what our ancestors ate. Right, now we're going to have a very quick chat to Paul, who wants to have a quick go at the quiz. Hi, Paul.
Hello, are you right?
Yeah, right. Well, I'm a bit stressed because I'm very short for time, but we're going to have a go at this anyway, all right?
Fire away.
OK. You have hairs in your nose to trap tiny particles of dust, dirt, bacteria and viruses. Is that fact or fiction?
I would say that is a fact. And I'd say they're also called cilia as well. Is that right?
No, the hairs up there stop large things going up your nose, and tiny particles of dust, dirt, bacteria and viruses are dealt with by your snot. Cilia are the tiny little hairs on top of your cells that kind of waft stuff around on the very surface of your cells.
Ah, never mind.
Unlucky, Paul.
Thank you.
But it was a good effort.
Thank you.
Thank you for joining us in on The Naked Scientist tonight.
Thank you.
OK, well, we're pretty much out of time. It remains for me to say thank you to everyone for phoning in with your great science questions this evening. It's been a pleasure having you all on the programme and for taking part in our Kitchen Science. Thank you to Derek and Dave, who are in Olivia and Ashley's kitchen in Kettering this week, where they were microwaving crisp packets. Thank you very much to the Naked Scientist production team. Petro Minch, Anna Lacey and Holly Barclay do a wonderful job putting this programme together and help us run it every single week. Thank you to you guys. But a very special thank you to our guest this week, Mike Hobson, who did an amazing job of answering all those impossibly hard science questions. Thank you very much, Mike.
My pleasure.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com. Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com.